This is the third day of the plenary, the penultimate one. So welcome very much to the session on bridging the digital divide with data, tools, and knowledge. This is built very much on GEO's long-standing efforts to promote full and open access to Earth observation data in accordance with GEO's data sharing principles. And in order for us to become instrumental to decision makers, the Earth observation derived products and services have to flourish in an environment which guarantees a number of enabling conditions. And these would include the adherence to the open knowledge principles that will be debated in the next point of our agenda, the legal interoperability among data licenses used by major providers of open data, the development of analysis-ready data, or the generation of results in a reproducible format. We have invited a number of speakers that will share with you their experiences to provide access to data, information, and knowledge across the world to bridge the digital divide and promote global equity. The panel will be moderated by Dr. Rybkina. So welcome, Dr. Rybkina, the Deputy Director of Geophysical Center of the Russian Academy of Sciences, Chair of the Laboratory of Innovation Projects, and Vice President of the Committee on Data of the International Science Council. So I have the pleasure to pass you the floor, Dr. Rybkina, and invite you to introduce your panel distinguished guests.
Thank you very much, John. So for the next 2 hours, we will focus on bridging the digital divide. And what do we mean by the digital divide? So this is the gap, as we understand, between people who are aware of the Earth observations and applied analytics, and there are people who are aware but do not know how to use it. So this is about the best practices and capacity development. And to achieve this goal, I will not wait anymore, but present to you our outstanding speakers today to share their best practices. And the first speaker is Mercury Fox. She's an NSF Merit Review Panel Fellow and works as a Fulbright Specialist in Science Diplomacy and Founding Director of the CODATA Center of Excellence in Data for Society. So Mercury, welcome to our panel. The stage is yours.
Hi, thanks, Elena, and good morning, well, good afternoon, I guess, everybody. I'm in Washington, D.C. Today, I am going to talk about the importance of open data in specific contexts and why different communities need access to open data to achieve their goals. So next slide, please. Thank you. So open data is important for national resiliency. It gives government agencies at every level the tools that they need to make evidence-based decisions, impose regulations, and to provide the services that improve resiliency. Sensory data improves predictive modeling that is used by agriculture, insurance, and construction industries, infrastructure planners and engineers, and emergency management services to mitigate damages that's incurred by floods, tornadoes, earthquakes, drought, epidemics, wildfires, pretty much all of the natural hazards, the disasters, the man-made catastrophes, really rely on real-time good sensory data in order to coordinate all of those efforts. As these events increasingly impact national economies, they interfere with the global supply chains. They interfere with employment stability and workplace safety, and they really have an impact on costs related to rebuilding infrastructure and just lost economic opportunities. So open data is a really important tool for policymakers and regulators and the business community and economic planners at all levels, from the municipal to the national to the international, to analyze these effects in real time and offset their impacts by providing immediate assistance where it is needed in the short term and appropriate investments in the long term. Disasters and catastrophes are the main reason that people leave their homelands. This has always been true, and it's true today. This is a worldwide crisis, and open data plays a role by helping governments and NGOs, nonprofits, and communities track movement and coordinate the response. That's at, again, every level from the United Nations to a local church. That is helping bring in migrants and working with those communities of people in need. Finally, damage to natural resources are often the most lasting and noticeable losses in a hazard. They affect both industries that are based on resource extraction, as well as the communities and the peoples who identify with the natural landscape. And in this way, open data helps resource managers and decision makers understand the growing frequency and severity of events that have traditionally fallen under local management, and to help people at the local level self-determine how they want to respond to the loss of place-based resources that have a great deal of meaning for them. Next slide, please. Open data is also very important to public-private partnerships, or P3s, as they are sometimes known. These are co-investments between government and industry that are designed to improve public services or to address gaps that neither sector is well suited to fill on its own. So P3s drive innovation in the public sector by supporting capacity building projects that might lie outside that government's jurisdictions or its purview to deliver services. Likewise, these arrangements reduce the investment risks to the private sector partners who compete for long-term contracts. The ability for both sectors to optimize open data assets underpins the public service business model. Open data improves credibility in P3 enterprise by allowing stakeholders a tool to oversee relevant inputs and to review the quality of outputs. And this transparency is especially important in capacity building projects, which require public confidence. And finally, open data represents a key return on the public investment related to the cost of collecting and curating administrative data and scientific data. This type of return on investment is not restricted to P3 projects, but it does hold the promise of achieving grand challenge goals. Next slide, please. Open data, of course, is important for cooperation. Cooperative research organizes the scientific community's efforts around shared common goals. So this is really science diplomacy in practice, and it's driven by the passions and the concerns that inspire people to become scientists in the first place. Open data helps investigators from multiple disciplines, regions, and sectors to identify and explore and pursue shared research goals in what is becoming known more commonly as convergence research, which is genuinely multidisciplinary, cross-sector, and often global research that can be year-over-year studies, longitudinal studies, but especially studies that require a lot of different kinds of experts from a lot of different disciplines. In a similar way, open data provides the foundation for evidence-based policies that drive the changes that our research findings tell us that we need to make. This also provides the basis for scientists and research institutions from different nations and cultures and ideologies to work together to advance those shared goals and to mutually benefit from new knowledge. And finally, Community engagement. Scientists use open data as a tool to engage stakeholders and to adopt important policies and regulations and systems at the community level, to work with communities and people that normally they wouldn't do in their, you know, in the regular course of lab work and of their research, and to travel to distant places, to the bottom of the ocean, to do lots of different kinds of work that might be a little bit outside of what they normally do in their research career. So open data is really vital to that whole extracurricular research ecosystem. Next slide, please. And of course, since I'm coming from co-data, I have to say, open data is fair data. Open data helps the research community verify findings and validate results. Data is a research output. It's a vital asset in knowledge production that other scientists use to help them map the interdisciplinary landscape. And data that can be shared, reviewed, verified, and reused has more value to the scientific community and to research sponsors than data that is lost, hidden, or locked away for limited use. And that is what I have to say today, and I look forward to questions. Thank you.
Thank you very much, Marjorie, for your presentation. You're perfectly in time. I have a suggestion to all our audience. If we will have, first of all, I'm going to have all our presenters today, and then we're going to run a question and answers session where you can have a direct question to our panelists, or you can have a question to each of our panelists. So please write your questions to the chat. I will track it carefully. And now let's move to our second speaker. And thank you again, Mercury, for your presentation. Okay, so our next speaker today is Jesus San Miguel Ayans. He's a senior researcher at the Institute for Environment and Sustainability of the EC Joint Research Center of the European Commission in the field of forestry. He's also the leader of the forest project, Forest Data Information Systems at the Institute for Environment and Sustainability. And more, that we're gonna have another speaker, Peter Moore, from the Forest Officer Fire Management for the Food and Agriculture Organization of the United Nations, where he leads their coordination on fire management projects. So welcome our speakers, and you have 10 minutes for your presentation. Thank you.
Thank you very much, Alina. It is really a pleasure to join you today with my colleague Peter Moore from FAO, with whom I've worked for many years. My presentation today deals with the Global Welfare Information System, which is in a way a good practice that has been implemented initially in Europe, and we are trying to extrapolate to the global scale. Please, next slide. Yeah, the Global Welfare Information System follows the same concept of the European Forest Fire Information System, which has been developed in Europe throughout the collaboration with the countries for over 20 years. So this is a system that has been developed for users, with the users. And the users, in the case of the European countries, are the fire services in the countries. The network of users or countries that are part of the EFIS network is currently 43. So it's a system that started with a few countries, 7 in the year 2000, and has been expanding through the years due to the gain that the users in the countries see in using a regional system. It deals with the fire cycle, starting with fire danger forecast before fire takes place, then near real-time monitoring of active fires and burnt areas, and then post-fire analysis of the impact that fires have in the countries and in the overall pan-European region. Please, next. The system has been built under the GEO umbrella, so it is one of the initiatives of the Group on Earth Observations, but with the support of two important programs. One is the NASA Science Applied Science program, and the other one is the Copernicus program. Being within the Copernicus program allows our system and our initiative to feed from other systems that are in place from Copernicus, such as the Copernicus Atmospheric Monitoring Service or the Copernicus Global Land Cover Service. Thank you. Next. In terms of near real-time information, the system provides data on fire danger forecast. And this fire danger forecast is provided for 10 days ahead of any current date. And it provides a series of indices that are currently used by the fire services, including the Canadian Fire Weather Index or the Australian MARC Index or the National Fire Danger Rating System. It includes also information on emissions. Please, next. This is what you have on the screen is the active fire detection from one of the sensors that is on board of the system, that is the MODIS. With spatial resolution of 1 kilometer, we are able to update the information in the system up to 4 times a day, because the MODIS sensor has 2 days, 2 passes during the day and 2 passes at night, which provide in total 4 updates of the system. Please, next. Additional information on active fire is coming from the VIRS sensor, also on board of NASA satellites, which provide also 4 additional passes during the day. So in total, the information on active fires is updated globally every day 4 times. Please, next. And we perform a near real-time mapping of burnt areas, which allows us to have an estimate of the areas burned globally and in every country, information on land cover damage, information on emissions, and information on impact, for instance, in protected areas or in different biomes, such as the Brazilian legal Amazon or the Arctic Circle. What you have on the screen are the areas that have been mapped this year, and in white circles, you have areas in which we have had fires over the size of 10,000 hectares. Please, next. In addition to the near real-time information, the system provides a series of data sets and graphs and charts for a series of data from 2002 until 2019. We are currently updating the information in the system for the year 2020 and for the year 2021. As I said, the data are for every country on Earth, and then it's divided by continents. Here you have the entry to the application. Please, next. Which contains information on number of fires and burnt areas for all the countries in a given continent. Additionally, we have information, please, next, on general overview of the country in terms of forest area, population, etc. And then we go into statistics of fire activity. Please, next. We have maps or maps and charts. The maps are of burning frequency within a country, seasonality of the burns, day of the year in which the areas are burnt, and then cumulative burn during a given year. And as I said, this is available, what you're seeing on the screen is 2019, but it's available for all the years of the time series. The data come from the MODIS product at 500 meter resolution. So it is fairly detailed for a global scale. Please, next. Then we move into the charts of number of fires and burnt areas, seasonality, information on land cover damage, etc. For the whole time series. You can compare any given year to the average or to any other year in the series. Please, next. and the same information for a single year, including fire size and the contribution of different fire sizes to the overall burnt area. Please, next. Finally, the last group of charts is that of biomass emissions. Currently, we have two databases, the one developed with the methodology of FAO, and the one coming from a global dataset of emissions that is called GFED. Please, next. And at this point, I pass the word to my colleague, Peter Moore, to provide the user's perspective on the system. Thank you.
Thank you very much, Jesus, and thank you, Elena, for and colleagues for the opportunity to be with you today and discuss these issues and aspects of the digital divide. As Jesus has just identified, the Global Wildfire Information System is a fantastic example of how to provide products and opportunities for people and countries to think of things. But I'd like to draw your attention to four aspects of the digital divide that occur. FAO, the Food and Agricultural Organization of the UN, as you would appreciate, is focused on its member nations, and the focus of those is on the member nations that really have significant needs or requirements or demands of the organisation. And predominantly they are developing countries. And so if I may, I'd like to introduce to you some ideas around the sorts of issues and context that those countries are working in. Often the nations, the institutions and the agencies don't have the physical capacity to access the data. Jesus and his team, with collaboration with us, have developed some fantastic country profiles. But if you don't have sufficient internet, or more often, you don't have electricity, then that's an issue. So there's a physical thing that we need to think about in terms of the Earth observing community about how we can possibly deliver things and help. Most of these are out of our control, but we need to be aware of them. The second thing is that they don't have the capacity to process and to use the data. So they can take a product that Jesus's team creates, or that many of the rest of you help to create and provide, but they don't necessarily have the capacity to then add value to that, to transform data, to create additional products, and so on and so forth. And then, so that's to do with the data, the Earth observing information, the data that we create. But then there's the operational aspects, the functional, the planning, the management aspects, which are to do with having the capacity to take a product and apply it to something. So in other words, a product that informs a decision, that stimulates an action, that results in some sort of improvement in the situation. And so there's a lot of developing countries that have limited or weak or mixed capacities in terms of being able to take a product from the Earth observing system, even one that's as mature and clear and available as what Jesus has just described for us, and then apply it in an operational way. As well as that, as you can imagine, every country is relatively unique in terms of its institutions, arrangements, its geography, its ecology, its sociology, its economics, and so on. And so they also need to have a capacity to take a product or take a data stream and then adapt it and apply it to their own context. And so there's another thing that needs some capacity building. It sounds like it's a very diabolical, weak situation. It isn't. There's a lot of positive aspects to it. There are a lot of people that have capacity, that are plugged into groups like GEO and CEOS, et cetera, that have the research capacity. But we do need to be aware that they're out there and that they need to build on this physical capacity, institutional capacity, to create operational capacity, and then to be able to work with the products we provide, the data streams we provide, to then adapt to their local circumstance. Thank you very much. Next.
Yeah, well, this is, we would like to close the presentation with a statement that was provided by Bowman, which called for an international initiative to gather information on forest fires or wildfires globally, because that was missing, and that is really needed for scientists and practitioners all over the world. So thank you very much for your attention, and we are ready to answer any questions. Thank you.
Thank you very much for your excellent talk and their best practice that you have shared with us today. So I'm still looking forward to any questions in the chat to run our question and answer session after the presentations. And now I'm happy to present to you our first speaker today, Omar Sidhu. Omar Sidhu is a member of the Interagency and Expert Group on the Sustainable Development Goals. He is also co-chair of Digital Earth Africa and serves on several other national and international platforms on data for development. Omar, can you hear us well?
Yeah, yes, I can hear you. Thank you very much, Alina. Okay, hope you can see my screen.
Yes, we see your full screen, so that works. Thank you very much.
All right. Thank you very much for having me. Yes, so I would want to look at it from two perspectives. As the co-chair of the TAC of Digital Earth Africa, and as someone with the responsibility of coordinating data for the Sustainable Development Goals in Ghana. As we may all be aware, the Millennium Development Goals was the first global framework guiding development within the African continent. And the lessons we learned when the MDGs ended in 2015 was that many African countries, including Ghana, could not measure, could not achieve the goal on environmental sustainability, partly not because there were no programs implemented towards that, but because we did not have access or the capacities around using some frameworks or some resources to measure. And so going into the Sustainable Development Goals and our own African Union Agenda 2063, which is Christine, the Africa we want, there was the need to ensure that the national statistical systems within the continent, who are now going to be saddled with an unprecedented responsibility to provide data for monitoring these agendas, have the kind of distinct approach that is needed to provide quality data for monitoring. And obviously, this responsibility requires effective coordination and leveraging non-traditional data, especially Earth observation. Ghana, as in many countries, the access and capacities to use Earth observation is limited. And this is where the Digital Earth Africa platform is seen as bridging the digital divide for the continent of Africa. And this is particularly so because the vision of Digital Earth Africa for providing routine, reliable, and operational data for the continent is something that sits well with the vision of the continent as captured in the African Union Agenda 2063. Particularly the areas of coverage through which Digital Earth Africa provide resources as land degradation, coastal erosion, urbanization, water resources and flood risk, agriculture and food security, and deforestation. And these are important areas that are required to ensure sustainable development within the continent of Africa. And also the principle around inclusiveness and diversity within the continent, where the resource is provided to the entire continent, is very important to achieve the goal of bridging the digital divide. So to ensure this diversity, Digital Earth Africa is working with already existing institutions within the continent, across the entire continent. And we are happy that the South African Space Agency is hosting the Program Management Office of Digital Earth Africa. And these are some of the continent-wide institutions that Digital Earth Africa is working with. Now, permit me to provide you some use cases of this platform. And the bias is that once I'm in Ghana, the preference is to use cases from Ghana. But then these use cases relevant to other African countries have been produced for those countries. The first is deforestation in a particular forest reserve within Ghana, where illegal gold mining is happening. And you can see that in the year 2020 alone, we lost 10% of the forest reserve. And this is instructive because we could not have been able to quantify how much of the forest reserve has been lost if not for this resource provided by Digital Earth Africa. Secondly, this is the resource is used to compute the natural capital accounting for a local government area, or otherwise called a constituency, being represented in parliament by one member of parliament.
It seems like we lost our speaker. Can somebody confirm this?
Yes, I can hear you, and I have lost the speaker.
Okay, thank you very much.
Me too.
Okay. So I suggest we might have like 1 minute to hear back from him. Probably he will just rejoin us. And if not, we will have to move to our next presentation. Yes, I think he has just connected. Omar, can you hear us now? We lost you for a while. Omar, please.
Sorry. You see my screen? Sorry.
Yes, that works.
Yeah. So the resource has been used to do this, and for one local area, and it is instructive to know that within this month, the traditional leadership of that particular traditional area, knowing that 10% of the natural environment is being lost through charcoal burning and other things, have instituted measures to ban charcoal burning and tree logging within that area. And this could not have been possible without this resource. Now, we have also used the resource to look at the availability of water in the Volta Lake in Ghana from 1985 to 2020. And this provided an important information to the institutions with the mandate around this. We have also traditionally been using population and censuses to understand urbanization in Ghana. And through the Digital Earth Africa platform, we are now able to use this to determine urbanization of the entire country and any local area within the country. And this has also been very informative. So what we have done through this resource is recently organizing a data fair for members of parliament of Ghana. And in this picture, why it is important for us is having the Speaker of Ghana's parliament and the leader of the House being introduced to this platform and how it can help support the development agenda of the country. And some members of parliament making themselves available to be trained or introduced onto how this resource could be useful for the people they represent. And this for us has been very important. In summary, the Digital Earth Africa platform is a program that provides an opportunity for the realization of the dream we have on the continent, Christian, the African we want. And it also provides us analysis ready, free, open, and accessible data for the entire continent through different products that have been developed. The services are also important for us because they touch on areas of importance, agriculture, water, forestry for us, and it helps us to measure our progress in achieving the Sustainable Development Goals and the African Union Agenda 2063, to ensure that the entire continent leverages this. There are resources available for free and self-paced learning, and every Wednesday there's live sessions that everybody within the continent who wishes to learn how to use this resource is provided. And these are the partners who have supported to put Digital Earth Africa together, and we are grateful to them all. Thank you very much. Over to you, Alina.
Thank you very much, Umar, for your presentation and your for sharing your practice. So I'm now happy to present our next speakers. So we're going to have two speakers who will present GEO Mountains. This is a GEO initiative seeking to increase the availability and accessibility of a wide range of data pertaining to mountainous regions. The first speaker is Carolina Adler. She is an environmental scientist, geographer, and executive director of the Mountain Research Initiative. This is a global research coordination network supported by the Swiss Academy of Sciences and hosted by their University of Bern. And the second speaker is James Thornton. He's also from Mountain Research Initiative, and he's responsible for the coordination and implementation of GEO Mountains. So up to you.
Thank you very much, Alina, and very grateful for the opportunity to join the GEO community this week, and in particular via this session. We're very pleased that we see the topic of open data and open science being discussed, and we look forward to also share some of our experiences and recommendations as well so far. Next slide, please. So just to give you a brief context and background as to why mountains, these are important regions that are globally distributed around the world. And so there are mountains in every continent of this planet. So it's important to recognize that they provide highly valued, tangible as well as intangible benefits for people and ecosystems everywhere in different ways. So it's important to understand how processes of change, be it biophysical, but also socioeconomic, affect the provision of things like water, for instance. These are also very specific contexts in which we can hone in to see how different changes and processes of change actually intersect in a given context. And especially given the way in which processes such as climate change are being observed, particularly accelerating in areas in mountain regions. So this is also an important aspect to consider, the challenging environment in which collecting data and indeed making meaningful observations of the changes that are happening in situ specifically can be then harnessed and harmonized, as well as compared with other regions. And many of the speakers already so far have made important remarks to that element as well. We need to make sure that we are integral to the needs also of that context. So this speaks to the last point there about there being universal but also region-specific characteristics that we need to be taken into consideration. Next slide, please. So about the Global Network for Observations and Information in Mountain Environments, this is a GEO initiative that's been part of the work program since 2016. And it's co-led by the Mountain Research Initiative and the National Research Council of Italy, both participating organizations of GEO. And within the context of the recent work program in 2020 to 2022, we were able to secure significant funding from the Swiss Agency for Development and Cooperation under the Global Program of Adaptation at Altitude, which has enabled us to pursue many activities and also regional connectivity to link up to the needs of mountain regions worldwide, and therefore also start the implementation of many of the aspirations that were part of our proposals back in the 2000s, and finally now being in a position to enact. Next slide, please. So just to give you a sense of what GeoMountains is looking at, there are many spheres of data and information out there. And in particular, it is important for us to be able to identify those that pertain to observations and information with respect to atmosphere, atmospheric, cryospheric, biosphere, as well biodiversity, hydrosphere and lithosphere. So this is ground and soil, as well as water. And how those intersect with the socioeconomic and human dimension spheres, if you like, particularly in regards to societal and governance, natural hazards and how they impact upon people and communities, and economic sectors such as agriculture, tourism, and others. So it's important here to also recognize the role that data providers, data users, but also the needs of local and global policy frameworks and conventions require, and of course provide a framework in which certain data and information is produced in that context. So GeoMountains has a new website, and we are building to now look towards developing, collecting, reporting capacity to be able to use the data and information to address those assessment and policy needs going forward. And with that, I would like to now hand over to my colleague James, who will look into more details about the open data and open science elements that are so crucial for the work that we undertake at GeoMountains. Thank you, James. Over to you.
Thank you very much, Carolina. Next slide, please. So being able to draw upon open data and science as inputs to our activities is really imperative. Equally, we recognize that we're only, in general, part of the chain from data to decision, and therefore we try to also aspire to meet high standards with respect to open data, transparency, and reproducibility, also for the outputs which we then pass on to our users. And so in the remainder of this presentation, we'll look at 3 specific examples from our recent activities to demonstrate some of this philosophy. Next slide, please. So the first example concerns in situ climatological observations of variables such as air temperature, precipitation, and snow depth, which are required by very many applications in mountains. We often hear statements such as, data is generally lacking in high elevation areas, or station density is much lower in the mountains. And whilst this is undoubtedly true in general terms, perhaps surprisingly, patterns of in situ data coverage in terms of spatial density, temporal coverage, and elevational coverage have not actually been comprehensively assessed yet. So to begin to fill this gap, we analyzed one of the most comprehensive and open global station inventories, the Global Historical Climatological Network inventory, across 290 mountain regions around the world using fully open and reproducible methods. Next slide, please. So the results include maps such as this one of mean station density by mountain range. So here, this specific case concerns stations which provide precipitation data, or similarly, maps of mean record length, for instance. Next slide, please. Or on the left here, we can also generate bar charts comparing the elevational distribution of stations within a given mountain range in blue with the underlying elevational distribution according to a digital terrain model across the range as a whole in green. And so we see for some mountain ranges, such as the Himalaya, which is the third pair along from the left, that actually the highest elevations are severely undersampled by our in situ stations. We also extended this to look at data coverage relative to some factors such as the hydrological importance of mountain regions and also the populations and economic outputs of their connected downstream regions. And so, for instance, the figure on the right here shows mean station density of mountainous areas against a measure of their hydrological importance, the so-called water tower index of Imizil et al. And on the far right, we actually see that the three most important mountain ranges in hydrological terms actually have extremely low station densities. And so this also serves as a very good example whereby we've been able to build upon work of others. And this is only possible because they actually made their data and methods fully open and accessible in the first place as well. Next slide, please. And so a potential application of this is really for global organizations to identify priorities for maintaining and improving in situ infrastructure in mountains. Next slide, please. The second example concerns really additional variables. So far we've dealt with 3 climatological variables at operational sites. Yet we know that in mountains, many measurements of both climatic and other important variables are made not by national agencies, but rather by individual research teams, universities, local and regional initiatives, and so forth. And so this is fantastic in that it fills in lots of the data gaps, but it does actually lead to a very diverse and complex data landscape in which understanding who is measuring what, when, why, how, etc. Is difficult to discover, to appreciate. Never mind actually accessing the associated data. So this can be very time consuming and challenging. And therefore we've collated a wealth of information from online sources and also historical information from the MRI archives into a single inventory, which we call the global, the GEO-Mountains in situ inventory of observational infrastructure. And this is available now, as we'll see in the next slide, from our website. And we also have a call to the community to help further develop this resource. And so if you could perhaps just press play on the video, that would be fantastic as well. We can just have a very quick look. So this is the web mapping application, which is available on the GEO-Mountains website, which seeks to represent the locations of the stations, and users can click on any station and obtain metadata about the measurements being made at that station and other information such as protocols, standards, and also where available, provide a link to actually download the data themselves. And so we feel that this, firstly, if you could go on to the next slide, please, has 2 immediate benefits. The first is that users can really discover what infrastructure exists and can access the corresponding data efficiently. But also, on the other hand, they can also contribute their sites and their data sets and thereby gain credit for their efforts and hopefully increase their impact as well. So it's really a crowdsourcing community or bottom-up initiative. And in the longer term, once our inventory is more complete, we'll also be able to do gap analyses, such as the one I just presented, but for different variables. Next slide, please. So moving on to the final example, there have actually been in the literature, both peer-reviewed and more grey literature, many very highly conflicting statistics presented on the number of people living in the world's mountains. And these estimates are crucial for many applications, some of which are listed in my first bullet point here. And the confusion has largely arisen because there are multiple ways of delineating the extent of mountainous terrain, and there are also multiple sources of population data. Yet traditionally, only singular combinations of these data sets have been used and the corresponding statistics reported. In addition, the methods have often been rather opaque. And so the upshot of this is that users of such statistics, especially policymakers, may have had very little idea about how actually the input data set choices could have affected the outcomes and the eventual decisions. Next slide, please. So to improve this situation, we conducted a comparative analysis looking at 12 unique combinations of mountain delineations and population data sources to quantify mountain populations, both globally and more regionally over recent decades. We show quite clearly that it's the choice of mountain delineation, which is the dominant driver of the variability in the estimates. And this work actually fed into the cross-chapter paper on mountains, which will appear in the IPCC Working Group 2 report when it's published early next year. Next slide, please. Some of the regional results are actually also particularly interesting. So for instance, we see that in parts of Africa, following on quite closely from the last presentation as well, that mean population densities in the mountainous parts are actually higher than the overall population densities, perhaps suggesting that in certain climates, mountains may act as refugia for people. And so we can think, of course, about what this could mean in the future for mountain population change under broader climatic and demographic scenarios. And just to mention also, this work was a collaboration with GEO-Human Planet, another initiative in the GEO work program. And so we've certainly benefited also from collaboration across the GEO work program. That's another important point and a recommendation for other activities as well. So in this case, next slide, please. So in this case, again, we used exclusively open data and software, as well as a reproducible script-based method. And we've developed a knowledge package featuring in the GEO Knowledge Hub. And I'll talk about this more in the side event on that topic later. And last slide, please. So this brings us, just the next one, please. So this brings us to the conclusions. And so essentially, as I hopefully have demonstrated, discoverable, accessible, and usable data of multiple types is really critical for GEO Mountains to meet our objectives. We're really pleased to see the gathering momentum around the open science movement, driven by funders, publishers, and also the community. And so we're supporting, for instance, the efforts of GEO in this direction around the GEO Knowledge Hub. We're really grateful to the providers of the open data and software we use. Without this, everything would be impossible. This must not be forgotten. But equally important is to work in a collaborative way across traditional boundaries, whether they be disciplinary, methodological, or geographic. So really, we need multiple elements to come together. And everything's not completely rosy, as also previous speakers have touched on. We've had some instances whereby we've learned that some meteorological and hydrological agencies still don't provide free and open data, despite them being actual members of GEO. So there could be some sort of disconnect, or perhaps the practicalities of implementing some of these open data policies are maybe lagging behind the political will in some cases. So just to say finally that there is still some work to do on this. Thank you very much.
Thank you very much. Thank you, James, and thank you, Carolina, for your excellent talk. So we're now coming to our last speaker today. Let me remind you that we are collecting your questions in our chat. And now let me introduce to you Krishna Balakrishnan from the India Institute for Human Settlements. Krishna is a project leader for the project that is founded by the GEO Amazon Web Service Cloud Credit Grant, and for the India Flood Monitoring and Impact Assessment Portal project, which is funded by a GEO Microsoft Planetary Computer Grant. So Krishna, the stage is yours. Welcome.
Thank you, Elena. Thank you. Hi. So maybe I should start by mentioning a little bit about the institution which I work with, the Indian Institute for Human Settlements. So we are a non-profit research institution focused on the challenges and opportunities of India's ongoing urban transition. So we are kind of focused on human settlements with a specific emphasis on cities and urban settings. This particular project, which is called the India Data Cube, as Alina mentioned, is funded by a GEO-AWS cloud credit grant, apart from other sources of financial funding. Next slide, please. Thank you. So the motivation for this project, in some senses, came from discussions with various policymakers and administrators. And the Indian Institute for Human Settlements, apart from the research component, has a very active program which focuses on training, capacity building, and also consulting with the government and administrators at multiple levels of the government. So one of the things which we repeatedly used to hear in some of these training sessions, and these are training sessions which are focused on basic analysis of Earth observation data for mapping urban extents and things like that. And one of the constant feedback which we would get from administrators and government officials would be that it's great to see that this is possible, but is there a simple way in which we can access this? Because they didn't really have the time or the capacity or the team strength to go into the details of the analysis methods which we were showing. So that brings me to the digital divide, and that really got us thinking on and got us working on a proposal of this nature. That is, the raw data exceeds, as many others have also mentioned, the ability to analyze and generate insights, and also, most importantly, to ensure the uptake of those insights by policymakers. In the context of India, apart from the large amount of Earth observation data which is available, while we have regular censuses and sample surveys, these are of insufficient temporal and spatial resolution. For instance, the census is only once in 10 years, and this year the census has not happened yet because of COVID. And while the sample surveys exist, they're not of sufficient spatial resolution. For instance, they are representative only at the level of the state, or maybe in some cases at the level of districts, but not beyond that. And this makes it very difficult to analyze in detail the living conditions of people. So the opportunity which we saw here is that we could integrate Earth observation data with census and surveys to help overcome some of these issues of spatial and temporal resolution, because the Earth observation data is now freely available, which has sufficient temporal and spatial resolution. The other point I want to emphasize is also that it's only in the past few years, maybe 5 to 10 years, that the data management frameworks, the methods, and most importantly, the computing power has become available for this. For instance, Landsat data has been available for 35, 40 plus years, but let's say 10 years back, if we wanted to try to do national scale analysis of that here in India, it would have been very difficult. And this is, I'm only talking about the analysis part, not about the uptake part. Now, as an institution, as I mentioned, IIHS focuses both on the analysis part of things and also the in ensuring capacity building and uptake of the analysis insights by administrators and policymakers. Next slide, please. So hence we proposed to build the India Data Cube, which consists primarily of deploying an open data cube to bring together time series data on remote sensing and the other statistical data sets, use machine learning and statistical methods to conduct integrated analysis of these data sets. And in terms of output, there are three main things which we are focusing on. The first is land cover, with a special emphasis on built-up mapping. The second is population, and the third is mapping of development indicators. Now, to implement this, as I mentioned earlier, considerable computing power is required given the size of the country and so on. And this is where the GEO-AWS Cloud Credit Grant was really instrumental in kickstarting this project, since it provides us access to the computing power required to conduct some of this analysis. Next slide, please. So the India Data Cube is built on many of Amazon Web Services, the services it provides, and which makes the framework and the data pipelines easily scalable. We use the open data which is available on AWS, and along with publicly available USGS data which is stored on AWS, to kind of assist in ensuring faster data indexing. What we've done is copy much of the data which is available in, let's say, an Oregon-based server of AWS, and create a new, what is called an S3 bucket, the storage service of AWS, in Mumbai, India, so that it's easier to perform the indexing into the Open Data Cube framework. Next slide, please. So now I'll briefly take you through a few of the outputs. These are like preview of ongoing work. We are in year 2 of the 3-year-long project. So in the next year, we are hoping to complete the time series analysis, build the access interface, which will enable multiple levels of access to this, as we shall see. So this here is a built-up map on the left hand of India. So naturally, it's quite difficult to see settlements clearly at that resolution, at that scale. So if you zoom into the black rectangle, which you see on the left image, that's what you have on the right side image. You begin to see some of the larger cities quite clearly, and the little black square right at the bottom, or towards the bottom middle, that's the city of Bangalore. That's where I'm speaking from right now. Next slide, please. We'll zoom into the city of Bangalore just to give you a sense of the kind of data sets which we are working on generating. So on the left, the top left, what you see is what we call the IDC built 30 meter, which is the India Data Cube 30 meter resolution fractional built up map. And here, when I say fractional built up, what we're referring to is if you take a 30 meter by 30 meter cell, which is typical of Landsat, the fractional built up, what we're referring to here is what fraction of, or what percentage of that 30 meter by 30 meter grid cell consists of impervious surface or human-made surfaces. So on the right, on the top right, we have the Sentinel-2 image at 10 meter. And at the bottom left, we have the world settlement footprint and the global human settlement layer built S2 10 meter. These are both 10 meter resolution open data sets, which are excellent resources for analysis related to built up and urban expansion and so on. So on the right side, you can see that we zoom into that little black square, which you see in the left image. So we're really looking now at a neighborhood scale. And on the top right, in the right side image, you can see the Sentinel-2 image at 10 meter resolution. So the top left is again the IDC built 30 meter. And bottom, we have the really global data sets for comparison. So we are really building on the methods and approaches which the World Settlement Footprint team and the Global Human Settlement Led team have published. And so this is really like building on their work and trying to improve it for a much smaller area, which is India. And on the top left, so you can see that the IDC built 30 meter data set is able to capture much more of the sort of variation in intensity of built up, which you can, I hope, see in the top right image, that is the Sentinel-2 image. Now, why is this important? Because as we shall see in some of the slides which come up, what we find is that built up fraction is the single most important variable for predicting population distribution. Next slide, please. So that brings us to the population mapping part. So on the map on the left again is a national scale 30 meter resolution population map, which we have generated. And that's the state boundaries which you see of India. On the top right, what you see highlighted in white is the state of Bihar, which is what you see zoomed in on the right side. So here a few words about administrative boundaries and scales of aggregation of population data. So in India, the census provides population data, but the data is typically aggregated to, in this case, if you take the state of Bihar, about 534 spatial units. These are the sub-districts, which I hope you can see in the light gray color over there in the map on the right side. Next slide, please. So our method is relatively simple in some senses because we are really using only one predictor variable, which is the built-up fraction, and a relatively straightforward geographically weighted regression method to redistribute the aggregated population, which is available at the sub-district level, to the 30-meter cells within that. So what we get is the population map on the left, which it's like a constellation of settlements, which you can see over there. But we'll zoom into that white rectangle. That's the city of Patna, which is the capital of the state of Bihar, and that's what you see on the right side. Again, here the top left image is what we're calling the IDC POP, the India Data Cube Population 30-meter resolution. The top right is the high-resolution settlement population layer, which is been generated by, through a collaboration between Columbia University and Facebook and several other entities. The bottom left is the 250-meter resolution global human settlement layer population, and the bottom right is world POP 100 meters. Once again, like I said, we are building on many of the methods which many of these other research groups have published, and building on some of their work, we've been able to generate this population map, which you see on the top left, which captures a much greater deal of the granularity and is considerably more accurate based on initial results, at least. Next slide, please. Thank you. So how do we assess the accuracy? This is a little bit of a tricky thing because typically the population can be mapped at the resolution of, like I mentioned, in the case of a state like Bihar, the 530 odd sub-districts. So what we did in this case is to essentially assemble a village and town spatial database, and there are roughly 42,000 of them in the case of Bihar. And this is data which is not easily available for the whole country. So what we are right now doing is assessing the accuracy using these finer grain spatial databases. So based on that, what we are able to see is that using only one variable, which is built-up fraction, we are able to come up with a population map which is of considerably greater accuracy than some of the other global data sets which are publicly available. So more details of this are available in the preprint, which the citation is given on the slide. Next slide, please. So after this, the next step in our project would be mapping development indicators. Right now, the cleaning and preparation of multiple tabular data sets like data from the Census of India, the National Sample Surveys, the National Family Health Surveys, which is India's equivalent of the demographic and health surveys, and the economic census are in progress. These will be linked to the administrative unit data sets. And then somewhat similar to approaches developed by the World POP team and several other organizations, we'll be using a Bayesian's spatiotemporal modeling framework to interpolate the geocoded DHS data, the demographic and health survey data. The spatial covariates for this will include some of the data sets like land cover, which we are developing as part of this project, and also other data sets like climate and topography, and also socioeconomic data sets, like, for instance, from the economic census. Next slide, please. The outputs from this, we aim to make accessible in 3 ways. One is, apart from, of course, downloading raw data sets and so on. One is developer access, where users can directly work using Python and R and other languages like that. QGIS and notebook access, where this can be kind of easily imported into a GIS framework. And the last, but in some senses most important from our perspective, is the geoportal access, where users can easily visualize and conduct basic analysis, since this is the piece which we really hope to emphasize and ensure uptake by policymakers. And all models and code related to the project will be made available via the Geo Knowledge Hub. Next slide, please. To ensure usage by administrators. So as I mentioned, IIHS as an organization has a program called the Urban Practitioners Program. And through this, we have been actively involved in training and capacity development of officials at multiple levels of the government. And over the past decade, we have trained nearly 6,000 officials across these different levels of the government. So in collaboration with this team, we'll focus primarily on the geoportal level of access and develop and deliver training modules related to this to ensure that they're able to use at least this level of access. Next slide, please. So I'll conclude there. That's the population map of India on the left. The email address is there in case anybody is interested in finding out more about this. And just as a last point, we are right now in the process of starting a new project which uses some of these outputs, like the population maps, in combination with other data sets, and especially a flood monitoring method to generate a flood monitoring and impact assessment portal. Thank you.
Thank you, Krishna, for your excellent presentation. So we have some time now for our questions. So our session was also live streamed on AirMeet, and as was reported from the GEO Secretariat, there were more than 50 people in attendance as well. So, and I see the first question that went from AirMeet, and this is actually a question to Dr. Moore. So Peter, the question is, have you or are you planning to use the Global Wildfire Information System data or tools in Food and Agriculture Organization of the United Nations documents and or projects? If so, can you share more details on that?
Thank you, Elena, and thank you for the question, whoever posed it. We're already using the GWIS. What it does, the country profiles provide us with an opportunity in the initial discussion with the country about its fire management circumstances to already understand how many fires in the last 20 years, what months of the year they happened in, their extent, which vegetation types they burned in. And for many countries in the developing sphere, this is information that they don't have themselves. It's not readily available. It's not able to be compiled simply. Now, there are obviously, as I'm sure you would all appreciate, that the remote sensing information is not precise or completely accurate, but it does give you a very good story, a very good illustration of what's happening in the country. And so we're already using we will be using it, for instance, in Myanmar next month to provide a starting point for understanding what the situation is. We've been using it in Cambodia. We had a look at it in Timor, Sudan, and so on and so forth. Now, many countries have the capacity to absorb more detailed information and process themselves. So the GWIS country profiles don't help, don't add particular value to countries that have that capacity. So it's definitely being used. I mean, the whole reason that we were engaged with the JRC, with Jesus and his team, to add this value to the Global Wildfire Information System was to provide countries with a ready-made set of ideas, set of products that could help them to sit and think about, okay, what time of year do the fires happen? Where do they happen? How big are they? What's their extent? And where do they learn? And that's one of the great benefits of Earth observation, is that it's an independent set of data that can be provided to a country for them to consider. So it's not, it has no politics around its presentation. So it's not from forestry, it's not from wildlife, it's not from research, it's not from academia. It's an independent set of information. That's an extremely valuable starting point to enable FAO and its partners and collaborators and the member nations to generate a discussion. And really that's what we're most interested in, is a discussion that leads to that engagement at the local level, understanding of populations, as we just saw from India, to be able to progress and work with things. It's incredibly important to have these products. As I made the point in the presentation, for most of us sitting around this table this evening, for me it's this evening, from you I'm not sure, things like electricity are not a given. You know, I've worked in many countries where the power would go off, the computer battery runs out, that's the end of what you do for the day. And so we need to provide products that can be downloaded and made ready that people can use. Now, that's not what they will do as they get more sophisticated and engaged, but it's what we can do, give them as a package, which is I think is very important. Thank you.
Thank you very much for your answer. We have the next question that goes to Mercury. Mercury, you were so great with your talk in opening our panel discussion with all the issues you raised around open data. So the question is, what are the greatest obstacles to open data sharing and how can they be overcome? Not the easy one. You have a bit of echo. Yeah.
Breaking up a little bit. You're breaking a little bit, but that is the question. So let me just talk about trying to target two areas: the socio side and the technical side. So, of course, from the technical side, I think we've discussed some of those concerns already. They are really related to capacity and the differences in capacity across regions. And so, for example, in an area like Kazakhstan, the downloading data can cost $5 per minute per gig. So that becomes, almost, cost prohibitive to run any kind of data, to share or access any kind of data. So that is related very much to technological capacity. Of course, there are more complex, sometimes political reasons that are involved in that. There are, any number of stakeholder issues that can range from simple lack of investment from, either a government or even from outside private investors. And that can, I think, currently reflects why we have a lack of capacity around the world to a great extent. And that is something that organizations like GEO can support and help with. We, can try to organize a little bit better efforts to raise that capacity. And we've seen some of that today in these presentations, as well as some of those efforts to advance that, but obviously that there's a long way to go. The socio side of it is, it's also technical, but it's really related to a lot of differences in who owns data and how data is shared, the governance and management of data that maybe multiple stakeholders might hold ownership claims to. And this also is work that is being done quite a bit on the sort of policy and law side, but unfortunately, there aren't a lot of people who kind of talk across those silos. And this is an area where personally I would really like to see a lot more people from the data science community in all of the research disciplines engage more deeply in how we want our data to be governed. And that goes right to things like data management plans and other kinds of processes for sharing data. So I would say just at these high levels, these are two things, these are two sides of the digital divide that can, stymie data sharing.
Thank you, Mark. Thank you for your comments. I have one more direct question, and this is question for Krishna. Outstanding talk. Thank you, Krishna. Could the methods be applied in Africa, or are they using Indian satellites? Thank you.
Thank you for the question. The methods which we have implemented so far all use Landsat data, and what we intend to do is, sorry, maybe I didn't mention during the presentation, the population work and the built-up mapping work, all of that is for the year of 2011. So from 2015 onwards, we intend to use a combination of Landsat and Sentinel data. In terms of being able to apply these methods in Africa, we haven't tested it out, but since the approach we are using is considerably simpler than many other existing methods, we are certainly hopeful that this can easily be transferred to a different geographical setting. In fact, if there are any opportunities to collaboratively work on this, we really look forward to that. Thank you.
Thank you very much. I think I have a question as well. And probably this question will go to each panelist today. So we have seen during our excellent panel talks that GEO brings together all the components of their information value chain to produce evidence-based for decision making. In some talks, we had best practices in the global aspect. In some talks, we had presentation of some case studies in a regional scale or in a scale of one continent. So the question is about interoperability between their global systems monitoring and regional system monitoring. So probably, first of all, I wish to hear from Peter or from San Miguel so you have presented your study based on the global coverage, but I'm sure that there are some similar systems working on the regional way. And in some countries, their decision-making is based on their regional systems of monitoring. So have you ever tried to bridge this between nations and their global approach?
Perhaps if I can start, Jesus, and then you can pick up. I mean, the global system was a concept that was championed partly by Canada, but also by the JRC, because there were a whole range of countries and regions that did not have ready access to remote sensing information related to fires and their management. And so that's the genesis of the system. It's evolved to be much more sophisticated than its original concept, so that now it has country profiles. So if you like, it's gone global to national. Mm-hmm. Rather than regional, and so that's something that's very, very useful at the national scale. As I mentioned, for the Food and Agricultural Organization, it's terrific to be able to say to a member nation that says, "Can you tell us anything about our fires?" Actually, hang on a minute. You can tell yourself something about your fires. Log in here, or not log in. It's not even log in. Just connect here. Do this. Etc. So that's fantastic. At the regional level, there are a number of regions that operate fire systems. So the European Forest Fire Information System, which Jesus is very, very familiar with and is the architect of, can do that. In ASEAN, the Association of Southeast Asian Nations, there's also a system that talks about fire danger rating and so on and so forth. We don't necessarily see, I mean, fires tend to be a national issue. I mean, land is a sovereign issue at the national scale. Regions often will be in a fire situation at a similar time. They may share ecologies, they may share landscape types, they may share ecosystems or economies or so on. So there might be some sense in thinking about solutions or problems or analysis at the regional scale. But that's not all. It tends to make things quite complicated. We do, and Jesus may talk to this, we do try and work to have regional networks where the countries talk to each other about things. And that includes spatial data, it includes Earth observations data, it includes meteorological information and data. It includes lessons learned and so on and so forth. So Near East and North Africa, North America, and at the moment, Jesus and I are collaborating on Latin America and the Caribbean. So the global, the national and the regional are not, in terms of Earth observation utility, are not necessarily, it's not that you step down from global to regional to national, because the spatial data is actually relevant at the national scale at a relatively local level initially. Jesus?
Yeah, I absolutely agree with your point that it is. So maybe I ask now Carolina for your comments regarding the GEO Mountains initiative. Do you have the experience with working with a very national and regionally focused data sets?
Actually, our experience has been that especially in the context of the Intergovernmental Panel on Climate Change and the inputs that were given in that context, it's very much coming from the global, but those data sets provided at the global scale can be pinned to the mountain delineations, if you like. And so we can be very selective as to the type of data and information we need to hone into those particular regions. What's particularly relevant for us in the mountains is the transboundary nature of biophysical, but also socioeconomic data. And the first speaker, Mercury, actually made a very important point about open data and open science also enabling science diplomacy and efforts to stimulate cooperation between nations, but also at the relevant scales. And for mountains, a relevant scale is indeed at the range scale, which means it's usually at the regional scale. But for us to say something meaningful at the global scale, we need to be able to have an interoperable and comparable basis to be able to say something about the different regions in the world. So yes, I think working at multiple scales is absolutely important. But for us, our focus has been largely at the regional mountain range scale. And here, perhaps my colleague James can also add further thoughts on that.
Yeah, just briefly to add, Carolina, I agree completely with what you said. I think there's a close relation between scale and sort of the resolution at which we work. And so I think Peter's last answer really said that, yeah, irrespective of the scale on which you're looking at, it's the same spatial resolution of data underneath, and that remains fixed. But I think for some applications in mountains, really, we do need information which is relevant at very high resolutions, because we have this complex topography, and many of the impacts of climate change, for instance, are very spatially discrete. And therefore, if that means that we shouldn't really do global analyses necessarily for the sake of it, if that means compromising on the local utility of the data, or at least we should be very clear about this analysis is useful at a global level for some high level applications, but actually you might need different data for looking at something on a more regional or local basis. So I think yeah, really we're seeking to work across these areas, but certainly, for instance, our analysis on the station coverage, this is something which could be interesting to global organizations, such as perhaps the World Meteorological Organization, to help fill in these gaps, working with the individual countries as well. Just to mention really that we have this sort of complexity or particular characteristics of mountains where we do see these strong spatial variability in lots of different components on very short spatial scales. So that's also something to bear in mind when we're talking about scale and resolution.
Mm-hmm. Thank you very much. Actually, I wish to follow you another question immediately that comes into the chat. This is a question to you, James, or to you, Carolina. You showed that in situ network for mountainous regions are quite sparse. Is there anything GEO could do to help with this situation, promote citizen science approach?
Yeah, if I can start briefly and then maybe Carolina can add anything. So we absolutely see an important role for citizen science. There's some very nice examples now emerging, particularly in the United States, whereby they're encouraging individual people who are in the mountains for recreation to contribute snow depth measurements, for instance. And I'm aware also in Switzerland, the snow and avalanche service also enable mountain practitioners to contribute measurements and observations into their system to help improve avalanche forecasts and things like this. So this is absolutely something we're very supportive of, and we would welcome GEO working further in this area, absolutely. And then I think the other side is really first the engagement with the national agencies to try to encourage all of their operational stations to be clearly discoverable and accessible. And then there's also this layer underneath, which I talked about, which is this very diverse landscape of data and observations from various different universities and other organizations. We have to somehow get all this to a common framework, and this is sort of what we're trying to achieve, hopefully, with our in situ inventory. And there are others, of course, similar, trying to do something similar, but I think it's sort of this convergence towards at least common metadata standards and providing the data where it's available.
Mm-hmm. I just want to briefly complement something that has been mentioned also as part of the work that's conducted in GEO, is the links to the private sector. And I think that's also a potential that we would benefit greatly from being able to establish meaningful connections around data and information also with the private sector. And this is something that GEO is already working very much in enabling. And we see a lot of potential there as well to make sure that we don't miss the opportunities to complement even further with what the private sector is already doing, especially, for example, in reinsurance, which is highly relevant for us in the mountains when dealing with natural hazards, for example. Thanks.
Thank you. Thank you very much. So here, I suggest we stop our question and answer session. If something left you wish to ask, you can always direct it through GEO Secretariat or to our panelist by email. And now we move from here to our general discussion and to the presentation of the open knowledge statement segment. So back to Chair.
Thank you so much. Thank you very much for that extremely inspiring panel, and also for the questions and answers. I'm really grateful for that too. But now we need to move on to the next point on the agenda, and this is the GEO statement on open knowledge that is up for adoption. And here I would like to give the floor to Marie-Françoise Vadreau. She's the Europe Director of Innovation Programs in the organization called Open Geospatial Consortium. And Marie-Françoise, the floor is yours.
Thank you, Joanna. And thank you very much to the speakers of the session that have set the scene so well for the statement I will present now. So as a continuation and an upscale to the GEO data management and data sharing principle, GEO has been working on an open knowledge statement that we want here to submit to the plenary And I will quickly summarize the goals and process that has been implemented to reach the statement as submitted today. This work originally came out of the concern from the previous GEO Secretariat Director, Gilberto Camara, who wanted to address remarks that had been discussed both in the plenary and in the executive committee that were related to how to make GEOs more results-oriented. And by that, the issue was how to make GEOs bring more evidence-based information that could be used for decision-making, how to implement a strategy for the results-oriented GEOs, and design, develop, and implement the GEO Knowledge Hub. Given the importance of the open science to capacity building, particularly with respect to the capacity of GEO members in developing countries to access and apply the solutions being developed through the GEO work program, the Secretariat asked the Capacity Development Working Group to assist in the development of an open science statement, making appeal to making available all aspects of an application development, from the methodologies that have been used, the data, of course, the algorithms, and all these being open and documented so it could be reused. A drafting team led by GEO, participating organization ITC, was assembled, which included members of the Capacity Development Working Group and others in the GEO community. This team produced the statement, which was presented to the program board and the executive committee about 1 year ago. This statement has been discussed and consolidated in the program board, but when presented at the executive committee at its 54th meeting in March 2021, the executive committee expressed, for sure, support to the concept of open science, but it recommended that further consultation with the GEO community be undertaken. This should include, of course, the data working group, particularly with respect to the alignment with the GEO's data sharing principles and data management principles. The document has also been presented in a spotlight session as part of the 2021 GEO Symposium to explain its purpose and its concept. From this broader consultation, a regular and key feedback has been that even if recognizing that science is a foundation for GEO's work, GEO is not itself a scientific research organization, but an organization which promotes science and its application within decision-making at many levels and in many contexts. GEO is much more than a science, and is concerned on providing value along the entire value chain from the Earth observation to the applications. For example, in the 2016-2025 GEO strategic plan, it is outlined that the arc of the data information value chain within GEO as identifying needs, ensuring the availability of data with which to develop information to address societal challenges, and transforming that information into knowledge through the generation of products and services for the end users. Further, in the Canberra Declaration in 2019, the ministers have reiterated the critical role that full, secure, and open sharing of Earth observation data and knowledge will play in deeper integration of Earth observation technologies into the digital economy. In reflecting on these responses, the Secretariat revised the statement to broaden it, moving from open science to open knowledge, so that this GEO statement on open knowledge may serve as a foundational document in support of the generation and sharing of knowledge, especially for decision-making. So this revised version of the document now and of the statement builds, of course, upon and broadens the previous draft statements. And the new document now emphasizes not only concept of open science, but also open access citizen and participatory science, open data, open reproducible research, open software, open infrastructures, open hardware, open education, open evaluation, diversity of knowledge, and overarching goals of open knowledge. The revised version was presented to the program board in its 21st meeting, end of September 2021. The program board has endorsed the refocus on the open knowledge, viewing the change as supporting the directions being taken into the 2023-2025 GEO work program. Some requests for minor revisions were made during the meeting, dealing with the recognition of unique features of traditional knowledge in terms of indigenous communities, clarification of the text on open infrastructures, open hardware, and on open licenses, as well as inclusion of references to open standards. These changes were made following the meeting, and the final version was circulated to the program board for confirmation and endorsement. This document has been presented to the executive committee at the start of the week that approved the presentation for approval to this plenary today. This is why, as a conclusion to this short summary of the lineage, process, and goals of the document, the program board recommends that the GEO plenary approve the GEO statements on open knowledge as guidance to the GEO work program and to the GEO community in general.
Thank you very much, Marie-Françoise, for that explanation, for the context, and for the summary. The statement is very much connected also to the GEO midterm evaluation findings 8 and 12. It is essentially a call for us, the GEO principles, to build upon knowledge that we have in the national data programs, and including endorsement of the GEO open knowledge statement and support to the GEO knowledge hub. May I invite now comments from GEO members? If you'd like to take the floor, please indicate in the chat. I just would like to remind that this document is up for adoption. Yes, the UK, please.
Good morning, good afternoon, or good evening. The United Kingdom welcomes the GEO Open Knowledge Statement and continues to support GEO's promotion and momentum building around open access. Thus, the UK thanks the Secretariat and contributors for their hard work on this, along with the presenters today, setting out just how open data can support and foster both the progress on common goals and profitable opportunities. The UK has been a long-standing supporter of open access principles and activities. Consideration should be given to the practicalities of implementation of this GEO statement as technology and associated data law develops, and it'll be appropriate to consider reviews of these principles at appropriate frequency to ensure they remain comprehensive, actable, and relevant. Thank you.
Thank you very much, UK. Also, thank you to China for the support that has been put in the chat. Any other comments? Thank you, Germany, as well. The United States as well. Thank you so much for your support. Norway. Okay, Norway is unfortunately not able to vote for approval at this stage, and France supports the open knowledge statement. Any other comments? South Africa, support from South Africa, Japan, Sweden. Seems there is widespread support, and Mexico too, thank you. So on behalf of the European Commission, may I also put in a little word to say that we see this as a good way to draw the attention of the GEO community topics such as open access, open data, and open software, and also the principles around the open science. And we welcome very much the references to GEO data sharing and management principles in the statement on open knowledge, and we support the adoption of the statements on open knowledge. So we have more support coming in, Costa Rica, Hungary. So thank you all. So if there's no further requests for the floor or no other comments in the chats, Switzerland as well, thank you, and Ecuador. Widespread support, so we can take this as adopted, the open knowledge statement. We are a few minutes away from 2 o'clock Central European time, and it's time to end this session as well. It is the GEO week is not over yet, but it has come, the time has come for the European Commission on behalf of the European Union to prepare for the next GEO lead co-chair mandate. As you know, we've had this lead co-chair role for the whole of this year. Before it was my predecessor until the end of September, and then the 1st of October when I took over his role within the DG of the European Commission in charge of research and innovation. Then of course I also was very glad and privileged to continue the role of lead co-chair. We are very proud of what we have accomplished during 2021 under the lead co-chair goals and objectives, which I highlighted Tuesday during my keynote speech. And based on the discussions we've had so far this week, it is clear that 2022 will remain a very busy year. It will require strong leadership in order to kickstart and see through the transformation of the outcomes of this week into concrete actions. Therefore, as of today, I would like to hand over now the GEO lead co-chair gavel to Stephen Volz, and we are very much looking forward to collaborate and support him under his leadership next year. So Stephen from the US will be chairing the plenary as of tomorrow. I therefore declare today's session closed. We are actually ahead of time this time. So thank you all for your very insightful presentations, interactions, support for the open knowledge statement, and also for keeping with the time. I also wish all my American friends and colleagues happy Thanksgiving today, and thanks for joining, and thanks for the session as well. So we'll see you all tomorrow. Thank you and bye-bye.